Hello, welcome to this short session on relative velocity. The definition of relative velocity is the apparent velocity dependent upon a frame of reference. So what we have here, if we look at our picture, we have one person standing still, but they're on a train which is moving away, and the person shouting, wait, hold still, and they're like, I am standing still, because it's all about the frame of reference that they're talking about. So we'll start off with a simple example. I have a man on a train, and what they do is, with the ball with respect to the train, they throws the ball forward at 5 meters per second. Now the train, moving with respect to the ground, is moving at 10 meters per second. How fast is the ball traveling relative to the thrower? Well, we've actually been given that information. As the thrower is traveling with the train, that means that we'll see that that is continuing to be 5 meters per second to the right. The thrower is in the same frame of reference as the train, so the ball to the train is exactly the same as the ball to the thrower, 5 meters per second to the right. Now, how fast is the ball traveling relative to an observer to the ground? So here we've got to think about the ball to the train and the train to the ground. So the relative velocities add up, and that gives us 15 meters per second to the right. So it's quite often we're thinking about objects moving to the left to the right, and you've got to think of adding up those relative velocities. Ball to the train to the ground, gives us a total value, which is the velocity of the ball to the ground. A common example of this will be boat problems. So what we have here is we have a boat traveling across from one side to the other, traveling at 5 meters per second. Okay. Now, its aim is to reach point A, but because the river speed, it reaches point B. If the speed of the current of the water is 2 meters per second to the east, calculate the time of the trip and the distance. So again, we're thinking about relative velocities, and here we have to combine the velocities. We will have the velocity of the boat and the velocity of the river. So if we were someone sitting on the edge, we would observe both of these velocities in play, and to work out the total velocity would require a combination of these two. But we have to read questions carefully here. It asks for the time of the trip and the distance between A to B. So think about how you'd answer this question. Let me take you through. So first of all, if we know that the vertical motion is 5 meters per second, and it's going to cover 40 meters. So the x is the width of the river, and v is the speed of the boat with respect to the river. That means it's going to take 8 seconds to get from one side to the other. Now this is useful information, because what we have here is x is the distance between the points A and B, and the speed of the river is now v, which is 2 meters per second, times 8 seconds. So that means we're going to go 16 meters, and that's the different distance between A and B. So that's some example of those.